recording. Okay. I was clicking on the wrong button. Okay, cool. So here we are. We are going to talk about the blockchain backdoor and how attackers managed to get into WordPress and used ENS to configure the C2. So this talk is regarding the CVE 2026-6443. And let me start presenting. Where's the presentation? Is that present? ये सब तो avoid करना है. Okay. We are going to talk about the CVE. There are a lot of big words here like supply chain attack, essential plugin, embedded backdoors. You may not know these things yet. Heck, you may not even know what WordPress is and how it works, right? So we'll cover things one by one and then try to match what happened with WordPress and what happened with ENS together, so you get the complete idea. So what is WordPress? WordPress is just a website building tool. If you do not know how to code, but you want to make a portfolio website or perhaps an e-commerce website, things like that, then you can use WordPress for it. Even NASA uses it, as you can see over here. Well, but how many people do use it? That's a great question. 42.5% of entire internet is built on WordPress right now. So it is a big deal. A lot of static websites are usually built using things like this, maybe some other tool like Drupal, but CMS is basically what is used for building these things. Now, is it only for CMSs, only for static? That's so 2000s. I need something fresh. I need e-commerce. I need fast business money, right? Scalability. Is that possible on WordPress? Of course it is. And in order to do that, in order to use your WordPress for e-commerce, you need a lot of these things. So you might need something for your card. You might need something for transactions like Stripe. You might need something like a payment gateway like this WooCommerce. You might need something to load the application faster like Contact Form 7. So these things are packaged as plugins on WordPress. Okay, do I trust them? Well, yes, they make your life easy. You don't need to code things from scratch. So that's a great plus, right? But should I trust them? That's where things get interesting. In order to understand that, I want to ask a few questions. Where does this website run? How do I even add a plugin? Who makes these plugins? And what permissions does this plugin have on my machine? Right? Until I get this idea, I don't know what WordPress really is. So let's delve into that. Well, WordPress is something that can run on your own server. So say I have a Linux server box, right? I'm just going to go to WordPress, download their package, and then set the server up. Once the server is up, I can host another database locally and connect it to it using the config file of WordPress. If I want to install anything, it is very easy on the dashboard itself, on the admin dashboard of WordPress. I can install any PHP plugins and things like that. So this is in general what kind of thing you run on your local machine. Now, where does this website run? Oh, shit, I think see, that's the thing, like I made these slides, but I'm kind of forgetting like where I was going with it. But yeah, okay. So before we delve into that, you need to understand that there's this important web config file. Now, this web config file is used to make sure that your WordPress server can talk to your database. And you can define things like that over here, as well as if you're using any sort of API keys, they also go in here. So this file is very important to us as well as to the attacker. Cool. Now that we have a general idea of where the website runs, I want to understand how do I add a plugin. In order to add a plugin to this website, say for example, I want to add,
What is a plugin?
What is a plugin बताना था, right? So how do I even add a plugin? So let's say I want to add something like an accordion. So accordion is a plugin that helps you create a dashboard like this where you have a lot of questions about the product, like how long does it last, what was used to make it, what is the warranty on it, things like that, so that they can click the plus icon, open it up and close it up. Super easy stuff, but why build it yourself when it's up there for free, right? So you want to get this guy. Well, you can go to the plugins tab in your dashboard. This is the administrator dashboard of WordPress. You go to this website, log in, click plugins. You can upload your own plugin by choosing your file from your local system, or you can choose any of the plethora of plugins available online. So these are the two ways that you can get the plugin. Great. So I'm interested in understanding, like, okay, it's easy to add these plugins, but who is making them for what? I don't trust them. I'm a cybersecurity guy, right? I am very, what do you say, skeptical about things. So let's understand that. So WordPress plugins can be made by individual developers or entire teams of developers. They can make and publish their plugins on their websites, and you can download them from there. What else did I want to say here? Yeah, that's pretty much it, right? And no other point here. Who makes these plugins? Well, okay, I mean, why am I saying that again? But why are they making these plugins? What is the motivation behind making these plugins for them? Well, maybe they are just happy to help. They were facing some problem during their development. They decided to, just gonna do it myself and make an app. And they're like, okay, you know what? I made it. I'm happy to have other people use it too. Or maybe they're looking for some money. Maybe it's like a freemium model where they give some services for free, and then the really good services you need to pay for them, right? So these financial motives or just a goodwill are some of the motivation factors. But what would make me choose it, right? There are a lot of these out there. So why should I pick one of them? So reputation matters when you're coming to plugins. I might be looking at the number of stars they have or the number of downloads they have, how long they have been up, right? These are a few signals that us developers usually go for when we are using something that we depend on, which is adding a supply chain dependency for us. Great. So what permissions does this plugin have? I'm welcoming these guys with open arms in my house, but what can they do once they are in? They can do a lot, surprisingly. By default, WordPress lets any plugin run with the same privileges that your website is running as. Say on your computer you have assigned a new user called web ID, web user, something like that, for running your website, right? So it has that directory. In that directory, it's basically God. So it can make database connection requests, it can make outbound network calls, it can have even access to the other plugins that you're having. So potentially other APIs or things that they are using, it has access to that too. And can this plugin update itself? Well, not really, not in the general sense. Like, obviously, they're not going to auto update things. You can go to your dashboard, you can click on the update button, and you can review, and then you can update things, right? So safe, right? But are you really going to do that? Maybe this first week you update it manually. The second week you start trusting it. You're like, yeah, okay, it's coming every week. I'm just going to set it for auto, right? And eventually you just click everything for auto. As soon as it comes there and there's a new version available, your your WordPress is going to auto update, right? So that's what usually happens. Great. Now you kind of have an idea of what WordPress is doing and how what kind of privileges the plugin has. It's kind of looking dangerous, right? So should I trust them? Absolutely not. All right. So let's get back to this CV 2026-6443. What exactly happened over here? So there was this team from India who were called Essential Plugins, and they basically decided one day that, hey, we have been working on this project for quite some time, and I think it's time to sell it and make some money, right? So they went to Flippa. Flippa is a website where you can sell digital assets, and they made a deal. They put it up for auction, and one of the highest bidders purchased it online. Now their identity is unknown. They used a dummy throwaway account, but at the end of the deal, they had access to their developer account on WordPress as well as all the code rights. So they can update the code and push it as they wish. Oh shit, that was another point that I should have mentioned earlier.
What point?
The point that talking about the who makes these, right? I was supposed to say that these are not vetted. You might be thinking that WordPress is looking at who is making these things, but it could literally be anyone. That is important to mention there.
बट मतलब कोई चीज़ अगर मिस भी हो जाता है ऑन स्पॉट तो इट्स काइंड ऑफ अंडरस्टूड तो उतना फर्क नहीं पड़ता.
That's true. But that's what this activity
Yeah,
is for. Cool.
but इतना प्रेशर लेने का जरूरत नहीं है. With all these things it's kind of understood anyway.
Really?
मतलब you forgot to explain how what is plugin, right? But तेरा पूरा process जो है उससे समझ में आ गया. We got the context of what is
Okay.
plugin.
Okay.
That's all.
Alright, so let's see what the adversary is going to do once he has access to the code. Well, all the plugins live inside their own PHP files, as WordPress is mostly built on PHP code. So for our accordion PHP, there will be an accordion slider PHP file. They're going to update that file and ship it. Now, as the laid back, easygoing administrator you are with automatic code, this code's going to come into your computer because of your auto update and execute itself. But hey, you're a smart guy, right? Of course, like you're gonna be on the cybersecurity news, you're gonna be on top of things. If something's reported malicious, you're going to find out and you're gonna throw it out, right? Obviously, come on, it's you. You're awesome. But perhaps you're too late. By the time you got to it, the plugin had created two files. One is a web shell file, and another is a persistent ENS beacon. Now, these files that it touched one is the WP comments post PHP. Right now, let me just clarify that this is an emulation. This is not the exact code that they ran, but this is our closest bet on what happened. So if you look at the word WP comments posts.php, there's an actual file called WP comments post.php. So they did a little bit of wordplay over there to make it seem less suspicious. Another thing that they did is they updated the WP config file, the important file that I was telling you guys about. So let's understand. Okay, yeah, I know that's too much code. So let's break it into steps and understand it clearly. The initial foothold. Now, if you look at the original code that they injected, it was having a URL, and this URL was fetching information like a long string from them and unobfuscating that code and placing these instructions to create the two files which it added there. These two files it created. Oh my god, I should get better at saying this short. Oh god. Okay. Whatever. Okay, coming back to initial foothold. The first PHP file that they ship to you, it contains one URL, and this URL's entire job is basically to fetch the code from their server and deserialize it and create those two files for you. So that's what they do in this slide. The web shell and persistent ENS beacon, they are all coming from these two. All right, so okay, yeah, maybe I kept that slide because of that. So they use this and they use it to create these two files, the web shell and the persistent ENS beacon. And because your WordPress is running as the web user and it has privilege to write in that folder, it is able to create these files over there in the same WordPress folder. Great. Now let's understand persistence. In the config file, this thing over here, the eval, is having a huge string in there which serves as the beacon that connects to ENS to resolve the C2. I know that's a lot, but in order to understand this, we need to understand ENS first. So just keep a note of this. We are going to come back to this, okay? So let's understand how this ship of WordPress connects to ENS. ENS stands for Ethereum Naming Services. It is basically DNS but better. Why is it better than DNS? Because it provides you decentralization, immutability, and the ability to bypass EDR and firewalls. Well, obviously, the third point is not that great for us defenders, but for the attackers, this is where things get good. Why do I say? But in order for you to understand these words, you need to understand what DNS is and what are the problems with it. So we are going to cover our basics first. Let's have a look at DNS. DNS consists of a structure of this sort. I have simplified it for example, but there are multiple such servers out there. Now, let's understand without getting into like what it stands for, what it does. Say if you want to resolve google.com, you'll basically make a request, a DNS request for it. And once this DNS request goes out, the resolving name server is going to be able to fetch it out because the resolving naming server caches the things that you frequently visit. Its entire job is to look for google.com, Facebook, things that you often go to and store them locally. But what if you're querying something that it does not know? Say one day you want to look for zombo.com. Well, obviously it's not going to know every random website on the internet, so it needs to make a few calls. The first person it requests is the root name server. It's going to ask him, hey, do you know who is responsible for everything that is com? And this guy is going to point you to the TLD name server for .com. Now, TLD name server is going to be responsible for everything related to .com. He knows who's who for the .com, right? So you're asking, dude, do you know who's zombo.com? And he's going to say, I know somebody who keeps that records from zombo.com. So he's going to send you forward to the authoritative name server. This guy's job is to store all the details related to the website, which is having that domain name. So he's having zombo.com's web server, email address, text records, everything, right? So this guy's got you. He sends it back to your resolving name server, and there you go. You're happy. You have your zombo.com resolved, right? So that is how DNS works in a nutshell. But why do I say that DNS does not have centralization? I'm saying that DNS is having decentralization. So why is DNS centralized? Well, if you look at the root name server, it is operated by an entity called ICANN. They are responsible for deciding who gets to control which domain, what record stays, what records go. They are the authority. DNS runs the way they dictate. If you go to the next level, which is TLD name servers, in every region, the domain names, top level domain names, have been assigned to one of these stakeholders who are responsible for all these names. For example, in Australia, we have ORDA, which takes care of every website that is .ua. There is VeriSign is responsible for everything.com, and there is also a company called .ai. I should probably figure that out, which one it was, who is responsible for .ai related domain names. So quickly you are able to see that there is a pattern going on. There is this Telstra sitting in the center. There's resolving name servers like your ISP providers, which are like Telstra. There are root level domain name servers like ICANN. There is this VeriSign, Cloudflare. So you can quickly see that there are these authorities responsible for each part of DNS. So there comes your centralization. These central authorities who have control over your data, your records. Okay. Now that we understand decentralization, I want to help you see why ENS is mutable. You remember these guys that we spoke about, right? So they essentially become the point of failure. What do I mean by that? Well, the authoritative name server's responsibility was to fetch the record of zombo.com and send it back to me, correct? But what if he himself gets pawned? If the attacker is now controlling your authoritative server, when I make a request for zombo.com, he's going to direct me to whatever he wishes to, because DNS was not immutable. He could change that record to anything that he wants, and now I, without my fault and for trusting the thing that I usually do, fall for it. Okay. So what about this bypassing EDR and firewall thing? Another point to mention that I should mention here, that this is not necessarily centralization is not necessarily a bad thing. It's good that the good guys have control of what stays and what goes. But this can quickly turn dirty if they start banning websites, they start putting restrictions on things, right? Because they have the pathway to connect you to things. They have too much power, basically. Okay, so let's get to DNS, right? So if I'm making a DNS query, I'm going to use a protocol called a DNS protocol, which is called Domain Name Resolution Protocol, which operates on port 53. Now, when I give these details to the SOC team, they're smart enough to put on their Wireshark and capture all the traffic, see everything on the SIEM tool, and if there is a malicious website that is being resolved, they can flag it right away, right? So this is present in DNS because you're making these requests. However, ENS does not use DNS, so there won't be any logs for you to see. Do you remember the accordion PHP file? I told you that it had this URL thing in it, right? So clearly that is a DNS resolving URL. So obviously if they're going to use this, then the SOC team is going to see that in the DNS logs and they are going to kick you out, right? So that is a problem for the attacker. DNS is making its life a bit easy to resolve the C2. So they need to do something better. What are the issues with a DNS again? Well, sinkhole, TTL, protocol anomaly detection. Wow, that's a lot of new words. Let's go one by one. So passive DNS surveillance basically means that if your malicious website is flagged once, they're all gonna know about it and they're going to hunt for it if they see it in the logs. As soon as they see it, they will block that IP, right? Sinkholing basically means these guys, the ICANN root name servers, they have the authority to take the C2 record off. So if you use it to resolve something, they can just as easily remove that record. The third thing is, say you're a smart attacker, right? So if the first domain got marked, you're obviously going to try to find another one which you can use in order to bypass that, right? But it takes too long. 5 to 6 hours of attacker time which is blocked, your entire botnet can be gone by that time. Cool. So obviously the attacker is in trouble. But is ENS the solution for him? Well, again, I have some questions. Am I going too slow? I'm going too slow. Pace is okay? Okay, cool. So in order to know if ENS is really the solution for attackers, we need to know how does ENS work? What is a smart contract? And can I even see it on my laptop? ENS is a completely unknown territory for us at this point, I'm assuming in this room. So I want to go a bit slow about it, right? So let's do a fun activity. I want you guys to scan this. Can you scan it? Let's see. Yeah? Okay. So I want you to search for Vitalik over here. If you notice, the Vitalik account says registered. That means that this domain name is already purchased by this individual named Vitalik. I want you to click on it, and if you click on it, it should take you to his profile. Now, if you go to the tab called Records on top, it will show you everything that he has stored on his vitalik.eth account. If you notice, there is Twitter handle, GitHub, avatar, URLs, and things like that. But if you go to the bottom, you'll see something called a content hash. So if you click on that content hash view thing, it will take you to a website. Okay? So it's that easy to configure a website on your .eth account. Now, instead of this, I can store any kind of record. I can keep my C2 address, I can keep my LinkedIn account, my Coinbase wallet, anything that I wish, because everything that is present in the vitalik.eth is owned by Vitalik. He gets to choose what he wants. That sounds like fun, right? all your public details under your control. You can change them whenever you want. Nobody else can change them. That sounds perfect. Exactly. But think about it. What were you talking to? You were using your browser, right? Where was that data coming from? Well, clearly you visited a HTTP page and they were getting the data from somewhere. But what is the blockchain then? If I'm just visiting on the HTTP protocol, then isn't that just normal web? Where's this blockchain coming from? We'll answer that question, but keep that thought in mind. Let's try to understand what is a smart contract. So, in order to understand this, I learn things better when I do them. Well, okay, so I shouldn't say that. Smart contract is a very simple thing to understand. It's just a Solidity file which is stored on the blockchain. Now, that might not make a lot of sense to you, so let's break that down a bit. I want you to visit these. Later. If you go to this one, you'll find this code over there, and that is basically what we're going to run today. It is, I don't like to go through the code. I want you guys to just run it and then understand what
People
it did.
will actually
Yeah,
do
you can actually do it if you want to.
phone पे तो नहीं होगा.
Yeah, phone पे नहीं होगा. So, click on the launch app, accept, and then you can see a new file. You just go to the contacts, create a new file. Okay. So once you create a new file, name it C2 demo, whatever you want, doesn't matter, and then paste the code from that in this thing. Okay. Hit compile. After you hit compile, it should show that it's compiled over here once done. And then go to the deploy and run tab. Okay, the logo looks like this. Once you're there, you will notice that there are a bunch of accounts that are set up over here, each with 100 Ethereum in it, right? So this is your virtual fake dummy blockchain that it has set up for you. Now, if you click the deploy button, it's going to basically deploy your contract for you. Okay, so over here, this is the C2 solve file that you saw. It's going to take that domain smart contract and deploy it. So once you deploy this thing, you can interact with it, right? So in our code, we had two functions that we created. One was the set C2 and another was the get C2, right? So let's use the set C2 first. I'm going to put in an IP 10.10.10.1, okay? And I'm going to hit transact. Now when I hit transact, you can see that Ethereum account which we used just has a little bit less money now, right? Because when I was putting this record up, it took some money. So can I confirm my address on the smart contract? How do I fetch it? Right? Okay, I can clearly see that we set it, but because the log entry is there, but can I fetch it? Can anybody else fetch it? Well, yes. Let's try the other method, get C2 that we created. Hit call, and you'll notice that money wasn't withdrawn, but we got our IP back. Okay, so here you can understand that sending or updating a record is costing you money. It might require you account details and things of that sort. But fetching a record does not require authorization, does not need anything. No money at all. It's free. So that's what a smart contract is. Anything else that I want to cover here in the smart contract thing? Yeah, I mean, that's basically it. Okay, another thing to say, so this is what a smart contract is. Now, when it comes to ENS, they are also having smart contracts just like this. A few methods that send things, a few methods that get things. But it's structured in a particular way. So we'll get that, but yeah. Can I even see it on my phone, laptop, per se, right? So, oh yeah, I have this slide, so I should jump to that. Can I even see it on my laptop? Oh, maybe this should be before. Oh, no. It should be here only. Or maybe... Yeah, this makes sense. Okay, so you got your C2 domain resolved. But did it cost you anything to see the address? When you were querying with the set function, it costed you some money. But when you were getting something, it did not require anything. No wallets, no account, completely anonymous. I just need to reach it, right? Well, that covers the smart contract phase. And the last thing that I want to cover, the next topic is, can I even see it on my laptop? Okay. But how did I reach it? Well, the website was able to reach it. It's having those records, right? It picked them from the blockchain. That's where it must coming. That's where it must be coming from. Correct. The website is using HTTPS. Can I do the same? Maybe. So essentially, we need somebody who can talk to ENS for us, right? We are sitting here on this internet side of things, and then there is ENS on the other side. This guy in the middle is Infura. He's a node provider. Okay, I'm jumping to things. Yeah. Okay. We need somebody to connect us to the other side. So let's see who that guy is. So these things like Infura and DRPC are the ones which form that bridge for us and help us connect to both the sides. They are called node providers. They translate protocols for us, so we can use HTTPS to communicate with P2P or RLPX on the other end. That's their job. So can I see it from my laptop? Can I even access it from my laptop? Well, yes. Usually if you have something like MetaMask, then it does the heavy lifting for you. It's going to do the KK computation, talking to Ethereum for you, and you don't need to do anything, right? But a hacker can't use it in WordPress, because in order for MetaMask to be on the WordPress, somebody needs to install it, and obviously you're not going to keep it for him, right? You're not going to give him all the tools he needs. So the attacker needs to be lightweight. He needs to not rely on third-party things and do this whole chain by himself. So let's talk about the steps that are involved here. There are essentially 4 steps. One is name hash computation, query registry, query resolver, and then decode the output that you receive. Let's go one by one. So I know it looks hard, but name hash is just some cryptography library things. You don't need to worry about that. The computer does the math for you, right? The next 2 things are just using a smart contract function, just like you did before, like the get C2 thing, just the same thing. These are 2 different smart contracts. One is called registry, one is called resolver. You just hit their function and it sends you some information back. And once you get that thing back, you just decode it with the standard decoding format that everything uses, and there you go. Okay. So you got this. Hang on. I know it's a lot that you're covering today, but you got this. Okay. So you remember, like, we went to this name hash thingy, right? I want you to scan this one. So if you go to this website, it should load. Reload. Okay. Just search tools ENS XYZ. Okay. Okay. ठीक है, I'll change that. So now go to the check an ENS name. नहीं, ये खुला? हाँ यही हाँ यही है
तो यही है
हाँ
खुला नहीं है फर्स्ट टाइम
okay so now that you're here in the check ENS, I want you to search for vitalik.eth. Okay, so you must have gotten his details down there, right? The important thing to note over here is the first step involves for querying anything, they have a standardization. So something like vitalik.eth, whatever your name is, it's all different size, different length, and different format, right? You can have different kind of alphabets. So they have one way to convert it into a hash, name hash, and then they store that on the contract name so that everything is standardized, right? So this number I'm getting from the metadata on this website. So if you go there, you're gonna see the metadata there, name hash. And that name hash is what we will be using. Following so far? Okay. Now there are just two, in step 2 and 3, there are just two simple smart contract calls. You remember, like, we created a smart contract, we had a get set function, right? Think of it like you're just using the get functions for both of these, and you're getting some different stuff. So let's walk through what it does, right? You have your name hash right now. You're gonna ask the first guy in his registry, hey, who is the resolver for this name hash? He's going to give you resolver 1. This is the second smart contract that it's pointing it to. So it contains records of name hash and resolver. Okay. Once you get that once you get the resolver 1 address, you're going to ask him, hey dude, what is the content hash for this Vitalik ETH thingy, right? So what is the content hash that you are storing? So this guy is the guy for Vitalik, right? So he knows the content hash for Vitalik. He is going to return this thingy for us. Okay? That's what we are trying to simulate now. Now, if you notice, there's this green colored thing in between. What does it do? So this green thing is... okay, sorry. That's not the point. If you notice, I'm using this green thing in between, which is a DRPC, similar to what Infura was. It's just another node provider, right? But why am I using DRPC and not Infura? Well, when I'm using Infura, it usually asks me for API key and authentication. It makes sure that it keeps track of who is requesting something. But DRPC, it does not ask me too many questions. It works without authentication with no API keys. Sounds good for an attacker because now he does not need to keep his own API key in the code that he ships out. And that's it. That's how ENS works. So I think you have an idea. So let's do it for real. Sorry. You remember this part, the web config thing, which I said that it's the ENS beacon and it's doing something? Well, what is it exactly? Let's break it down. Now, this string inside there, if you base64 decode it, it's supposed to just become the code that I'm giving you here. Okay? So if you go to this one, you can view the code. Up to you. It's just one page, one PowerShell script. So that should open HTTPS RPC JSON PS1 for you. Okay, so this is just a script file with those basic steps built in. Now, I'm taking a few shortcuts here so that nobody else with the code can recreate this thing. I'm going to pick that name hash from that website that we saw earlier and hard code it there. Okay, but in a real world scenario, you'll have to import libraries and things to compute the KCAC name for you. So this name hash thing, you're not gonna get it from scratch. You need to have libraries there to compute it for you. The next thing is call the registry, right? So in this step, the first smart contract that we had, we are going to try to make a call to it. We are going to say, hey, I have the name hash OXEE, okay? And that is kept here, name hash. I should probably highlight that, right? The name hash thingy. So you're gonna query it for the name hash, like, hey, I've got this name hash, can you give me the resolver back, right? And he's gonna reply with the resolver contract name. Okay. The second request that I'm making is using that resolver address that we got, and we're going to ask it, hey, what is the content hash for this? Okay, so we make the second request, and it's going to give me back the raw hex format of the content hash string. Step 4 is decode that string, and after some decoding, I managed to get the same IPFS URL that was present on that website, right? So the content hash here and the thing there matches. Great. Hacker's really happy. This stuff is working out for him real well, right? So at the end of the day, what you're doing is you have your attacker ETH account, you're shoving that inside HTTP JSON RPC and making a request. So how do you defend this? Okay, here it's important to mention, like, because this is happening, there are not going to be any DNS requests. There is only going to be HTTP request, right? That means the things that you were doing before are not going to work anymore. That's why your SOC team is in trouble. So how do you defend this? Well, you remember that green thing that I was talking about, the DRBC guy? Who is he at the end of the day? It's just a node provider, right? His job is to query the ENS for you. But I don't need it for my web application. I'm just gonna block that shit. If I see any HTTPS request header pointed at DRPC, I'm going to cut the connection straight up. Easy fix, right? Nice, I like that. We can just block DRPC. Fantastic. That's gotta work, right? There are thousands of node providers. DRPC is just one of many. We can't block everyone, they keep coming. So what else can we do, right? Perhaps keep checking for beaconing behavior. I said that it's making HTTPS JSON RPC requests every 6 minutes or so, right? So what if we we are on a lookout for these requests? Well, the problem with that is that on the surface, they all look like HTTPS requests. So you can't really identify it. It's kind of difficult. That's possible, but that's not the best way to look for it. Is there anything else? Yeah, well, do you remember that KCAC function I was talking about? Well, we took a shortcut when we were taking the Ethereum name and converting it into the name hash, right? But when I'm using a crypto library for doing that, I can just check my computers using something like a EDR, endpoint detection. What the fuck is that? EDR is endpoint detection and response. Yeah, if I'm using a EDR tool, I can simply look out for KCAC library usage of that, and once I see it being triggered, I can catch it, right? Well, by far, that is the best solution that we have. If you see a name hash computation from a WordPress website, that user process that started it does not need to start a KCAC library. It does not need to use KCAC library, so that's an immediate flag for me. So this is one of the most obvious ways to stop it. Okay, now quiz. That's pretty much it. Like, we are at the end of it. Okay, bonus questions for the experts in the room. Why did the attacker not use ENS in the first place? You remember that first file which I showed you where the URL was encoded? Well, that's obviously going to make a DNS request, right? And that will be flagged. So why didn't they use ENS from the get-go? Any thoughts?
What does this fetches their?
It fetches their website.
Their website.
Yeah.
So their website is not in ENS.
Yeah. Exactly. It's not on ENS. They are making a DNS call here.
Because it's not on ENS as well.
Yes, but why didn't they use ENS here itself? यही URL जो है वो ENS पे डाल देते और फिर ENS यूज करते हैं रिजॉल्व करने के लिए, या इसका जो IP एड्रेस है वो डाल देते हैं ENS के ऊपर डायरेक्टली रिजॉल्व करने के लिए. तो उन्होंने यहाँ पर हार्ड कोड क्यों किया DNS क्वेरी? ये तो पकड़ी जाएगी, ये तो आज के डेट में भी पकड़ी जाती है. बट it is more reliable. It's like a two-punch combo. They'll catch your DNS, but they wouldn't necessarily know that you also have a backup ENS going on. And by the time they figure out your two files are already created and no network connections are being made which will hint any suspicions, right? So sure, catch the DNS, but keep the stealthy ENS for yourself, right? So ENS is for stealth, not for initial. The second thing is that mostly, if I'm dumping something, I want to be lightweight. Now in my initial getco itself, I cannot shape the entire KCAC library in the plugin. It will be flagged very easily, right? I want to make minimal changes in the first code that I deploy. So if I'm just not shipping the library, my ENS probably won't work in the first time, right? So the DNS success rate is way more significant than ENS. I'm spraying and praying with this kind of attack. My job is that most of the computers that have this plugin should get impacted, right? And that's going to work on DNS. Once I'm in, I'll set up the heavy infrastructure of ENS later. That's the plan, the long-term game that the attacker is playing here. Cool. Next question for you. What if attackers use custom ENS resolvers and return malicious C2? What I mean by this is you created a smart contract yourself, right? You had control on writing the method. Yeah? Now standard ENS has a public resolver function, right? It's like, hey, we have already built this stuff, just use the same contract. You don't need to code the contract yourself. But you can very well make your own custom resolver. You use the same function names, you return the same format, but in the function, you can put if-else conditions. Yeah? So if somebody which is having the IP of your target subnet, right? You return your malicious C2. But if they are in a sandbox environment, which is not belonging to the target range, then you return a normal website. They'll never catch you. Right? So what is the defense for this? I don't know. Okay. Another question. What happens when Web3 P2P becomes common? I'm saying today you're having this kind of structure where this HTTP JSON RPC is there and you can put your smart header requests thingies on your tools to catch anything going through the DRPC, right? But tomorrow, when the world moves to Web3, they'll be reaching you through P2P. You have to enable your P2P. They don't need this guy to talk to the other side anymore because everybody is on this side now. Now, what do you look for? The standard techniques that I told you, like the KCAC thing, that library, right? It's gonna fail. You need KCAC for everything now. Everything resolves through ENS. So that library function will be needed. You can't flag that. You can't look for JSON RPC either, because nobody's using that anymore. Now that becomes a very big problem. I'm going to leave you with this feeling of dread. Thank you so much. That was me and Adam.
Awesome.
Yeah? Okay. How long did I take?